All right, let's talk about something huge, cloud security. Now, don't worry, this isn't going to be some super complex, code-heavy deep dive. Instead, I want you to imagine you're an architect. You're designing a brand new, high-tech digital headquarters for your company. And your job is to make it incredibly powerful, but also rock-solid secure. So, let's grab our hard hats and start laying the foundation. And that's the big question, right? Think about it. Your marketing team needs access to their floor. The finance team needs to get into the super secure vault, and you've even got automated cleaning robots that need to get into every office. You can't just hand out a master key to everyone. That would be a complete disaster. This is the absolute core of what we're talking about today: smart, secure, access control. So here's the game plan for our grand tour. First, we're going to look at the actual blueprint of our digital headquarters. Then we'll write the official rulebook for who gets to do what. After that, we'll start handing out the keys to the kingdom, learn how to build some seriously cool virtual security walls, and finally, we'll make sure that security foundation we're building is absolutely solid. Okay, first things first. Before we can even think about handing out a single key card, we have to understand the layout of the building. In the world of Google Cloud, this structure is called the resource hierarchy. And trust me, it's the blueprint that everything, and I mean everything, is built on.
Think of it like this. It's actually pretty intuitive. At the very top, you have the organization. That's the entire headquarters building. Now, inside that building, you have folders. These are like entire floors dedicated to a specific department. Finance gets the 10th floor, the shopping app developers get the 11th. On those floors, you have projects. Those are the individual offices. And inside the offices, well, that's where you find the actual resources: the computers, the servers, the file cabinets, all the stuff people use to get their work done.
Now here's where it gets really interesting, and it's a super important rule to remember. Permissions flow downhill. If I give you a master key at the top level, the organization level, that opens every single door in the entire building, then guess what? By default, you can get into every floor, every office, and open every file cabinet below it. This is called inheritance, and it's an incredibly powerful concept.
But what happens when you need an exception to the rule? Let's say your developers have owner access for the whole building, so they can set up new offices. That's fine, but there's no way you want them wandering around the super sensitive finance floor. Well, this is where you can apply a specific deny rule right on the finance folder itself. And here's the crucial point. A more specific deny rule will always override a general allow rule from above. So they can still get into the shopping floor, no problem. But the finance floor is now completely locked down for them.
So we've got our blueprint, we understand the layout, now we need the official security rulebook that's going to govern our entire headquarters. In Google Cloud, this rulebook has a name, IAM, which stands for Identity and Access Management.
Now, IAM can sound pretty complex, but I promise you, it all boils down to answering one simple question. Who is asking for access? What exactly do they want to do? And which specific resource are they trying to use? Let's break down each one of those pieces.
First up, the who. This is the identity that's asking for permission. It could be a person, like you or me. It could be an entire team managed as a Google group. Or, and this is super important in the cloud, it could be a non-human. Think of your automated scripts and applications as helpful robots roaming the building. They need their own secure identities to do their jobs. Next, we have the what. These are the specific permissions. This is the list of approved actions. Are you allowed to just view a document in that file cabinet, or do you have permission to actually edit it? Can you start a server, or can you also delete it? Being really specific here is absolutely fundamental to good security.
And finally, which resource does this rule apply to? This is what ties everything back to our blueprint. We're not just saying you can view files, we're saying you can view files, but only in this specific project office on the shopping floor. It's this powerful combination of who, what, and which that lets you create an incredibly precise and secure policy.
Okay, so blueprint, check. Rulebook, check. So how do we actually enforce these rules? Well, we do it by handing out different kinds of key cards. In IAM, we call these roles. And there are really two main types you need to know about. On the left, you've got primitive roles. These are things like owner, editor, and viewer. Think of these as master keys. They're simple, sure, but they are wildly powerful and you should be extremely cautious with them. Now on the right, you have predefined roles. These are way better. They're like a specialist's keycard. A network admin's keycard only opens network closets. A database manager's keycard only works on the database servers. This is so much more secure because it follows a core idea called the principle of least privilege. You only give the exact access someone needs to do their job and absolutely nothing more.
And hey, here's a massive pro tip. This comes straight from Google's best practices. When a new person joins the marketing team, you don't craft a custom keycard just for them. No way. You just add them to the marketing group, and that group already has the keycard with all the right access. Then, when they leave the company, you just remove them from the group. Boom, access revoked. It is so much simpler and safer than trying to manage hundreds of individual keycards.
Remember our robots, the automated systems? They need keycards too. And that's exactly what a service account is. It's a special identity, a special keycard that's used by an application or a virtual machine to securely access other resources. It's a keycard for your code, not for a person. And it lets your automated systems work securely without you ever having to share your own personal password. All right, we have nailed the essentials: blueprints, rulebooks, and keys. But you know, a truly high-tech headquarters has the really cool stuff too, right? Like laser grids and biometric scanners. So let's take a quick peek at the digital version of that.
Let's think about a very real problem. Imagine an analyst. They have the right keycard to view sensitive financial reports. They need it for their job. But what's to stop them from just downloading all of that data, sticking it on a USB drive, and walking right out the front door? How do we stop sensitive data from leaving the building, even if it's done by an authorized person? The answer is an amazing feature called VPC service controls. Think of it like this. You can literally draw a digital fence around your most sensitive projects. You create a secure perimeter, a digital vault. And once that fence is up, data cannot leave that perimeter. An authorized user inside the fence can work with the data, but they simply cannot copy it to a location outside the fence. It is an incredibly powerful defense against data leaks.
Wow, okay. That was a whirlwind tour of our new digital headquarters. We've covered a ton of ground, from the basic blueprints all the way to digital laser grids. So let's just take a moment to lock in the key takeaways you need to build that truly secure foundation. First, your resource hierarchy is your blueprint. Plan it out well, and security becomes 10 times easier. Second, always remember that I am mantra: who can do what on which resource. Third, please use the specialist keycards, the predefined roles, instead of the master keys. Fourth, make your life easier and more secure. Manage access for groups, not individuals. And finally, don't forget about your robots. Give them their own secure keycards using service accounts. And that's really the heart of it all. See, great cloud security isn't about some single magic tool. It's a strategy. And it all begins with that solid foundation, properly managing identity and creating a clear, logical structure for all your resources. The good news is, you now have the essential architectural knowledge to do both. So the final question is for you. You've got the architect's tools in your hands now. You have the blueprint, you've got the rulebook, and you know how to make the keys. The foundation is laid. The only thing left to ask is, what amazing and secure things are you going to build? Thanks for joining me on the tour.